Hi guys, in this video I'll be talking about penicillin. Okay. Now penicillin is basically naturally occurring antibiotic. As we all know, it's a naturally occurring antibiotic from Penicillium notatum. Now penicillin, the first naturally occurring penicillin was penicillin G. Okay. Then it comes to penicillin V. Okay. Then finally semisynthetic penicillins like the penicillin group will be same, that is 6-amino-penicillinic acid, the main precursor of the penicillin antibiotic. Plus with that modifications are done, like few chemicals will be added as a side chain or something like that. So the main thing that is, it has the beta lactam ring. Okay, it has a beta lactam ring, which is the main structure of penicillin. This is the main structure of penicillin, the beta lactam ring. Remember that. So that is why penicillin are also called beta lactam ring containing antibiotics. Okay. So if suppose you guys have a questions in your semesters that what are the beta lactam ring or what are the beta lactam antibiotics, it means they are asking about the penicillin. Now what happens in case of beta lactam ring? This penicillin, remember that this penicillin is basically cell wall inhibitor. They are basically cell wall inhibitors. They just block the cell wall synthesis. Okay, they always block the cell wall synthesis. Now, what is the mode of action of this penicillin? It is very important and very common question that comes in your semesters. Always remember that penicillin always inhibits the cross-linking reaction in between the peptide bridges in PDG. Okay, always remember that penicillin always blocks this reaction. Now how? This is the mode of action. Now what is the mechanism of this action? How they will inhibit this reaction? There must be some mechanism. So first enzyme, which is very important, that is transpeptidase enzyme. Okay. Now this transpeptidase enzyme basically helps in this cross-linking of the PDG layer. In this PDG layer, there is NAM and NAG. I have already made videos on this. And there is peptide, pentapeptide linkage and all. That will make the PDG helixes, PDG branches. So transpeptidase is the main enzyme which plays very important role in this cross-linking, so that the PDG will form in a proper way. But here the penicillin, remember I have already told it has a beta lactam ring. This structure is very much similar to D-alanine residue present in this pentapeptide bond. Okay, pentamino acid bridge which is formed that have the D-alanine residue, and this beta lactam ring of the penicillin, whether it's G or V or ampicillin or amoxicillin, whatever it is, the main beta lactam ring, it resembles, it has a structural similarity with the bacterial D-alanine residue of the peptide bridge. Okay, so what happens here? Competitive inhibition occurs. How? As the penicillin is analogous to the dealanyl-dealanine residue of the bacteria itself. This transpeptidase enzyme cannot differentiate in between this dealanine or this penicillin. It thinks that, okay, if penicillin is supplemented or if it is applied to the bacterial culture, transpeptidase, it cannot differentiate. It doesn't have that much perfection or ability to differentiate in between dealanine residue of the bacteria or whether it is penicillin, the antibiotic itself. So that as this penicillin is very much similar to this structure, often this penicillin that will bind to the transpeptidase enzyme. So penicillin here is the competitive inhibitor for dealanyl-dealanine residue. For what? For blockage of the transpeptidase enzyme. Because if this residue binds with this transpeptidase, reaction will proceed in a normal way. PDG layer will be formed in a normal way. It will give the original cell shape, structure and all. But if penicillin is applied for the treatment of the bacteria, obviously the penicillin, they tends to compete with this dealanine residue, and that will bind to this transpeptidase in the active site of the transpeptidase and thus blocking this enzyme. If penicillin binds to this enzyme, that will block this enzyme, the transpeptidase. So it obviously blocks the PDG layer synthesis, means the cell wall synthesis will be inhibited. Okay. Now there is another very important thing you have to remember, that in case of the bacteria, PDG layer is making the formation of the PDG layer, that is in a process. The process is on right now. It means the bacteria is actively growing. Right now bacteria is actively growing. If a bacteria is actively growing in its exponential phase, or it's actively growing in a medium right now, means its growth is not completed yet. Penicillin will act on those bacteria very well, because once the cell wall synthesis has been completed, in case of fully grown bacteria, penicillin will not work as efficiently as it will work on the growing bacteria. So please keep it in mind that growing bacteria rather than a fully grown bacteria are more sensitive to penicillin. Okay? Because once the cell wall or the PDG layer has been formed completely, there is not a need to transpeptidase blockage. Okay? That is why penicillin should be applied in the growing bacteria, not the full grown or an old age culture of the bacteria. Suppose you have culture a bacteria, incubate it, and then you keep it in the fridge for storage or -20. After 7 days you just applied that antibiotic on the same plate, and this penicillin will not work on that old bacterial culture. It will definitely work on this growing bacterial culture. This is the explanation of this. So this is it. This is the mechanism or the mode of action of the penicillin. Thank you so much. If you like this video, please subscribe my channel and share with your friends.